Hi everyone, this is R V Kiran, Assistant Professor, Department of Mechanical Engineering. Today I am going to deliver a lecture on Advanced Materials subject, and this is my second lecture on this topic. So today I am going to discuss about the topics of PRC FRC Structural Composites and its applications. So I have used the short forms of the PRC. PRC means particle reinforced composite, FRC fiber reinforced composites, and structural composites. So in the first slide itself, we are going to classify the classification of composites. So this is the basic classification or classification based on the reinforcement type. So first we are going to divide the composites into three types. First one is the particle reinforced composites, second one fiber reinforced composites, and third one is the structural composites. Again, particle reinforced composite is divided into large particle and dispersion strengthened. Next, fiber reinforced is divided into continuous fibers and discontinuous fibers. So this continuous fibers has other name, that is aligned fibers, and discontinuous fibers has other name as short fibers. Again, discontinuous fibers have been divided into aligned type and randomly oriented type. And last one is the structural composites in the classification, and the structural composites can be divided into two types. That is, the first one is the laminates and second one is the sandwich panels. So this is the brief classification of the composites. So in the classification, first one is the particle reinforced composites. So here we are using a particle composites which consists of particles of one material, but it will be dispersed in the matrix of the second material. So we are taking two materials here. One is the matrix purpose, other one is the reinforced purpose. So the reinforced particles are dispersed in the matrix particles. So first one is the large particle composite, and this particle size is 1 to 50 micron meters. So this size is varies, depends upon our personal purpose or research purpose. Next, commonly used large particle composites are concrete and ceramides. So on the side of the slide we are seeing a pic. So that is the large particle composites, and there are some small gaps filled by the reinforced composites. And second one is the dispersion strengthened composites. So in the dispersion strengthened composites, it is uniformly dispersed and it has a fine grains and harder grains than the large particle composites, and the size is less than the 0.1 micron meter, and these are used as the reinforcement purpose only. The general dispersion strengthened composite used nowadays are nickel. So on the side peak we are seeing the matrix as rubber and particles as carbon. So carbon material is a stiffer material, so which develops the stiffness of a matrix, and the matrix used here are the rubber. So rubber has some elasticity property. So we are seeing the material as automobile tire. So in the automobile tires we are using the two materials, that one is the matrix is rubber and particles are carbon. So the gray color or darkish color comes from the carbon particles, that is reinforced particles only. So on the bottom of the slide we are seeing some particle reinforced composites we have seen in day-to-day life. So that one is the turbine fan, and next one is the cardboard or bread hub. Next one is the folder type composite. These are the examples and live examples of particle reinforced composites. And second one is the fiber reinforced composites. So in the fiber reinforced composites, the mechanical properties depends upon the fiber properties, that is short fiber or long fiber. So that depends upon the length of the fiber particles or fiber reinforcement we used in the matrix. Also the load applied on the fibers, that is on the matrix phase. So these are the mechanical properties which depends upon the fiber reinforced composites. And a good interfacial bond between fiber and matrix is very much needed in the FRC, that is fiber reinforced composites. Depending on the matrix material also, it can be divided into three types. So they are PMC, Polymer Matrix Composites, CMC, Ceramic Matrix Composite, and last one is the Metal Matrix Composite, that is MMC. So these three are classified depending upon the matrix material. And next one is the alignment of fibers. So we are using the fibers as the reinforcement purpose and filling the gaps of the matrix. So when we are using the aligned fibers, so aligned fibers means it have been aligned in a particular manner, that is parallel or perpendicular way. But in the second one we are seeing the random fibers. Random fibers means randomly oriented short fibers. So these are randomly dispersed in the matrix. Third one is the discontinuous and randomly oriented. So discontinuous means non-aligned fibers. So non-aligned or short or long fibers are mixed in the orientation. Next one is the discontinuous and aligned fibers. So in the discontinuous and aligned fibers, the fibers used are mixed with short and long term fibers, but the alignment is continuous. So the alignment is parallel or perpendicular. And fifth one is the continuous and aligned fibers. So here the alignment is parallel and continuation of fibers is long. So long fibers have been used here. And last one is the fabric type of fibers. So in the fabric type of fibers, we are using the parallel way and perpendicular way. So both ways are used in this alignment of fibers. Next one and last classification is the structural composites. So in the structural composites, we have classified into two types of structural composites. First one is the laminar composite and second one is the sandwich panel composite. So in these structural composites, it consists of both homogeneous and composite material. So homogeneous means which we were used in the daily life, and a composite materials is also used in the structural composite. And compared to other composites, these properties depend on the characteristic properties of materials as well as geometric design. So here geometric design means what is the shape of the object, so what is the capacity of the object, what is the load bearing on the object, so what is the composite used. So these are all considered under the geometric design. So based on the geometric design also the properties depends on the material. So and the characteristic properties. So characteristic properties means, so if we want elasticity, we used to define some elastic materials. So if we want stiffness matrix, we want to decide and we want to take the stiffness materials. And if you want tensile strength, we want to use the iron or stainless steel. So these are the characteristic properties of the constant materials, and these are also depends on the geometric design. Geometric design means which we are giving the initial design purpose. So in this bottom pictures we are seeing the first one is the laminar composite and second one is the sandwich panel. So first one is a laminar composite. Laminar means layers. So here we are seeing the laminar composites slide. So in the laminar composite it consists of number of sheets, so which are two dimensional. Two dimensional means only depends on the x-axis and y-axis, so that means the two dimensional, and these panels preferred directions to achieve high strength. So number of panels are used in these laminar composites which strengthens the directions on two dimensional. So such successively oriented lanes are stacked one above the other directions. So stacked means put on one side of the layer. So if we are placing a lamina over the other lamina, that is the meaning of stacking. So keeping side by side or keeping one over other. So here we are seeing some of the examples of laminar composites. So that are cemented. Cemented means one lamina is stick to the other lamina. So on the right side bottom corner we are seeing the different types of laminar composites here. So on the first one it is in the aligned way, which is on both directions, x direction as well as y direction, sorry. Next one is the cemented reinforced composite, which we are used in between the two dimensional lamina. And in the third picture, so here we are seeing in the third picture they are using polymer matrix. So we are using a polymer matrix and reinforcement is the woven cloth. So woven cloth we are using as the reinforcement. When the load is acting on the polymer matrix, the woven cloth is moved on one side of the object, that is on the load applied side. So here we are seeing right side is some applied load. So we have some applied load in the right side, and left side there are no deflections. And last slide is the pressing on both sides. So when we are applying loads on the both sides, the matrix or the material is appeared as same that like one. And next second one is the sandwich panels. So these sandwich panels are low density and honeycomb in structure. So honeycomb means తేనెటీగలు. సో when we are discussed in Telugu, honeycomb అంటేనమ్మా మనకి తేనెటీగలు తేనె పెడతాయి చూసారా, సో అట్లా చిన్న జల్లెడలాగా ఉంటుంది అనమాట. హనీకూమ్ కోర్ అంటున్నాం దాన్ని. సో దాన్నే ఇక్కడ ఇంగ్లీష్లో హనీకూమ్ కోర్ అంటున్నాం. సో దీస్ ఆర్ లో డెన్సిటీ అండ్ honeycomb core. So this has the purpose of lightweight and large bending stiffness, that means the elastic or plastic stiffness. So sandwich panels are generally light in weight structure and has low density. Density means weight here. There are low density. Next, the core materials used are rigid polymers and foams. Foams means there are two types of regularly used foams. First one is the polyurethane and second one is the epoxy. And we are using wood as another layer here and honeycombs as well in the middle of the sandwich panels. So in the restaurants and other food streets we have seen the sandwich regularly. So on the sandwich there are multiple layers. One of the bread layers are there, next onions, next green leaves. So many layers are there. So here also sandwich panels consists of different types of layers. So first one is the general lamina material or reinforcement material, second one is the resin material, third one is the matrix material, and it also consists of the honeycomb core also. So on the bottom of this slide we are seeing the sandwich panels here. So first one is the face sheet here. So we are considering it as the face sheet. So face sheet means we are seeing the sheet on the sandwich panel right there. And second one is the adhesive layer. So adhesive layer means epoxy or resins used in the sandwich panels. And third one is the honeycomb core. So third one is the honeycomb core, and these are combinedly stiffened and making as a panels. So different types of panels are used here, and these are used as the sandwich panels. So materials of these panels are considered upon the purpose of the research or purpose of the experiment we are doing, but the core is the honeycomb core here. So the fabricated sandwich panel is seen on the right side of the bottom corner of the slide. So all are attached, so all panels are attached, and the honeycomb core is clearly seen there. And the applications of this classification, and these classifications means fiber reinforced composite, particle reinforced composite, and these structural composites applications are used widely in automobile industries. So automobile industries means highly they are using the aluminum and steel bodies. Second one is the marine applications. So here marine applications, in the marine applications they are used in the racing boats and hulls means shallow objects. And third one is the aeronautical applications of aircrafts and rockets. So both business and military purpose are used here. It also used in the missiles also. And fourth one is the antenna used for the communication purpose, and also in the electronic circuit boards, that is PCB or breadboards. So these are the applications here, and thank you.